Hi, I'm Kian, and today I want to teach you how to find if a series is convergent or divergent. So we have this series, we don't know the formula, but we have the terms. It's 1 over natural log of 2 to the power of 4, plus 1 over natural log of 3 to the power of 9, plus 1 over natural log of 4 to the power of 16, and plus 1 over natural log of 5 to the power of 29, and so on. So if we see, using the properties of natural logs and logarithms, we can bring out the power. So we can write this as a 4 times natural log of 2. And also we can write this as 9 times the natural log of 3. This one as 16 times natural log of 4. And this one as 25 times natural log of 5. So the formula, because we're starting with 2, I want to write the formula as from n is equal to 2 to infinity, and then the formula we get, 1 is a constant, so always have it. And then we have, because a perfect square is being multiplied, so we have n squared times natural log of n. And if you put any value of n, you see that it works. So now I want to see if this series convergence or divergence. So I want to use the direct comparison test. So first, I want to use a series that I know that it's convergent or divergent, and this is related to this series. And if we look at it, we can see that 1 over n squared is a very good choice for us to use it as our example for a known series. So we can write it as the sum from n equals 2 to infinity of 1 over n squared, and this is using a p series because 2 is greater than 1. We can say by p series this converges, and if found fact that this converges to pi squared over 6 from n equals 1 to infinity. So now we have an example. So we can form inequalities to find if this original series converges or diverges. So our inequality is the sum from n is equal to 2 to infinity of 1 over n squared natural log of n. Because it converges, then it should be less than or equal to the series from n equals 2 to infinity of 1 over n squared. And now, because the summation notations are the same, we can cancel out these two. And if you cross multiplication, and this is n squared, if you cross multiplication, you get n squared is less than or equal to n squared times natural log of n. So now, because we're starting with n equals 2, we want this inequality to be true for numbers greater than or equal to 2. And if we solve this inequality, if we divide both sides by n squared, the result would be 1 is less than or equal to natural log of n. But is this true for number 2? This is not. If you plug in 2, natural log of 2 is less than 1. So it cannot make this inequality true. But with this, after this, we cannot say that this series diverges, because if we put 3, we see that it works. Natural log of 3 is greater than 1. So we can make a conclusion that for n is equal to 2, it doesn't work, but for n greater than or equal to 3, it is true. So we can make a conclusion that because we found and find a value of n that can be greater than or equal to some number and make this inequality true, so we can make a conclusion that the series from 2 to infinity of 1 over n squared natural log of n is also converges similar to 1 over n squared, and by the direct comparison test. Thanks for watching. Please subscribe and let me know what to do next.